Okay, maybe we start with a quick introduction. First of all, hello to Finland. I'm sitting here in Hamburg in Germany, not too far away basically. Pascal is a little bit more south in Stuttgart. And we are happy that we can join here today and explain you a little bit something what we are doing here in Germany and surrounding countries basically with buildings according to the cradle-to-cradle design system. Here's our agenda. So we start first of all to introduce ourselves. Yeah, so my name is Markus Diem. I'm an architect. I'm the head of office here in EPEA Hamburg. We are around 35 people here in the office in Hamburg. And my experience is quite related to China, to Asia. I was 15 years in China as an architect, and for 2 years I'm working with EPEA now. And my focus before I came here was on green building design. And because I think materials and cradle to cradle is the next level, basically, we need to let us challenge, basically. I decided to join EPEA here. And Pascal, maybe you say something about yourself quickly.
Sure. Hello, everyone. My name is Pascal Kepler. As Markus already said, I work for EPEA in Stuttgart. Where we have our head office and our sister company, Dresden Sommer, is located. I work for EPEA since 4 years now as a cradle-to-cradle consultant for the built environment and construction. Mostly responsible for the development of the tools that are necessary to do that, and also have been in some scientific projects where we developed further principles how to optimize buildings for circularity. And I myself, I'm not an architect, I'm an environmental engineer. So that's kind of the complementary topic to Markus. So there's a lot of different people working at EPEA.
So I think we're a good team, Pascal. Great.
Yeah.
Okay, so let's go about quickly. I want to try and tell you something about who actually is EPEA, because EPEA is basically the company which was founded in 1987 from Professor Michael Braungart, and he is the head behind the cradle-to-cradle system. So cradle-to-cradle is nothing new. This is 30 years old. Michael started to found Greenpeace, the early Greenpeace days. Michael Braungart was with it basically. And he had this idea that in future to use products basically in a better way, it needs to circulate in circles basically. We will explain this a little bit later. 2001, the famous Cradle to Cradle book was published. It's still quite, a lot of people buy it. Always depends if there is Michael Braungart in the news somewhere. In Germany, he is very often. Then basically in 2009, the Ellen MacArthur Foundation came to Michael Braungart, and they had a long workshop here in Hamburg. And afterwards, basically Ellen MacArthur Foundation promoted the word circular economy. And the circular economy is nothing else than cradle to cradle thought in a wider way, basically. Yeah, and cradle to cradle is basically powering the circular economy. In 2010, there was the cradle-to-cradle certification system established. I will go a little bit deeper in this later as well. And important to mention is that since 2013, EPEA has a quite close cooperation with the company Dresden Sommer, which is the largest German product management company. And in 2019, Dresden Sommer took over the major shares of EPEA. And the reason is that Dresden Sommer, with its 4,000 people, is usually involved in every construction project in Germany. The company is just believing that cradle to cradle and materials and circle is the next step. So first came energy efficiency, and now we are in materials basically. And that's why we did this merger. Quickly about EPEA, we are 45 employees overall in 6 offices in Europe. So the head office is in Hamburg basically, because this is where the company comes from with 35 people, and the real estate team with Pascal, they are mainly sitting in Stuttgart. So now I would like to point out what is our challenge, because yeah, this is the reason that I talk to you basically, is that we have a lot of materials in construction industry, and after the usage time of a building, they are demolished like you see in this photo, and they are just, we don't really know what's happening with the materials nowadays. Some are still recycled, but we call this downcycling. Because if a facade window becomes a water bottle or a beer bottle, that is not upcycling, that's downcycling. And the structures are not well set yet, so there's a big issue. And what's also interesting to understand that this is actually a slide here which shows you a little bit about the material consumption in the construction industry. So we always talk about energy, we make buildings more efficient. On the other side, we forget that to reach this efficiency, like for example, with insulations, we need to use a material. And what's happening with this material? This is the big issue. And here you see basically that the construction industry is responsible for actually more than 50% of the complete waste on this planet. So it's a big challenge for us to avoid waste and become circular. Okay, so the next thing is that nowadays we have a big problem. We are mostly spending our times indoors. 90% of the time we are indoors here in Europe in average. We use more and more different materials. Yeah, there are more and more chemistry coming into the materials, and it's not always known what these chemistries are doing to the human health. So there is a visible increase of people having allergies, basically. And the allergies, the source often is that bad materials are used, which basically have bad indoor air quality, and this is what makes people sick. And we have huge problems here in Germany, also with schools, for example, where the indoor air quality is so bad. And I think this is a big challenge, and this is the right answer, is to use healthy materials in these projects in future. Why is this basically? Yeah, this is basically because back in the days, like 200 years ago, 100 years ago, we did not have so many different materials, and the building quality of the building envelope wasn't as good as today. So there were a lot of gaps, it wasn't really airtight. So bad air basically could move out, was ventilated out. Then we came to the thing with saving energy. So we sealed our buildings. We even make blower door tests. So this basically has the consequence that all the toxic material, the harmful materials which are already inside, they are trapped inside. And that is the problem which you see in the second little graphic here. And where we need to go is we need to keep our buildings in an insulation system, basically, that we use less energy, but the materials inside the building need to be healthy. And this is the big issue, because if the materials are healthy, there is no bad, harmful stuff inside the building. For example, Michael Braungart always mentioned that sheep isn't red wine proof. Yeah, you can buy a carpet, you can buy a natural carpet and you put it on the floor. It's sort of made out of sheep wool. But of course, the industry is adding chemistry to make it red wine proof. And what's in this chemistry, a lot of people, or we, for example, we don't know. So this might be harmful material. Here you see now something of this harmful material, which is, basically in our lungs when we are inside an enclosed space. So our solution basically is starting with the cradle-to-cradle design concept, which I would like to explain quickly. So here you see where we are today. This is the linear economy. We harvest a resource, we design it, we make it in a way that it's functional, and it should be basically cheap, because it competes on the market with other products. The problem is we don't know what's inside. So now we have more and more things that we repair stuff, we reuse stuff, we downcycle stuff. But the issue is always that the content of the material isn't known. So we don't know what's going on with it. It's not defined. The only thing we have sometimes is it's free of. That's basically happening if harmful substances in the media, then the companies say, okay, I put this chemical out, but we still don't know what other chemicals are in. Yeah, this is the big issue. I give you another example, for example, the ocean plastic. Yeah, we hear a lot about it. Companies nowadays make big advertisement. They say they save the turtles in the sea, they save the fish, they take the PET bottles out and make textiles out of it. Yeah, this is of course a first step that people think about it, but it cannot be the last step because this photo shows it pretty well. Where does this shoe go later? Yeah, it might end up in the ocean again. So this is not closing a circle. This is not cradle to cradle. This is just giving a little bit of a time difference before this material, which is just designed badly, is becoming waste again. So the solution is, these are the two circles that I mentioned before, is that materials of products, they circle in a biological cycle and a technical cycle. This means everything which is used off, basically, for example, like a tire, the rubber is coming down, that is coming into the nature, into the environment. This is stuff which should be in the biological cycle because it's out there in the nature. Other materials, like for example, for a cell phone, the plastics, the metals, this would be all circling in a technical circle. So this is the basic idea of cradle to cradle. I cannot go so deep now to explain much more, but there's two circles. If you keep this in mind, this is already a big thing and it works with most products in this world. I mentioned before that there's also a cradle to cradle certification system. This is becoming more and more popular nowadays. And here I explain you a little bit something about it. What's special basically? Special is that it's internationally and you can use it for all different products over a lot of different industries. And what it does is it's having a look at the material health. This was what I was explaining all the time, that a product needs to be healthy. It looks how you can reuse a product. It has a look as well as how is it produced. So the factory where the last step is basically done, we audit this factory, then we look for green energy, for water, and for social fairness. This, for example, we are also going for textiles to Bangladesh, and there you know that there sometimes is the issues that children are working in these facilities. That's of course under cradle to cradle not possible. Yeah, so our people are going there and having a look. And what is special about cradle to cradle, you see that here on the left side a little bit. This is, we go deep into the supply chain. So we are not stopping at the last company who's producing the t-shirt. We're also looking at the company who's doing the printing inks, who's doing the yarns or whatever. Yeah, so we really know deep down to the detail of the product. We have a look and know basically everything. Cradle to cradle is sometimes people ask if this is also a building certification system. No, it is not. Cradle to cradle is only a product certification system, but buildings are made of products. So the products inside a building can be cradle to cradle certified, and this is basically a benefit for the building then. And the green building certification program like LEED, GGB or BREEAM, depending on which system, they give bonus, they give benefits if you use cradle to cradle products. Here we have a little example for the LEED system that if 20 of the permanently installed products are cradle to cradle certified, bronze level or higher level basically, then you get points in this LEED system. The system itself has a cradle to cradle basic and then goes to bronze, silver, gold, and platinum. Okay, so now we go to the buildings. Why does it make sense for buildings? 1 second, I have a technical issue here. I don't see that. Okay, it's coming. So here is the rule again, is first the material is safe, is healthy, then we design for circularity, and then on top, it should have a positive impact. What does that mean? I'll explain you here quickly. This is, for example, a customer that we are working with for many years, I think 12 years now. company was called Deso. Now Tarkett took them over. What you see is a carpet. It's called Airmaster. This carpet is designed in a way, it's made out of 100% nylon polyamide, and it can be recycled 100%. And Deso is not selling carpets anymore, they're leasing them. You can lease a carpet for 10 years, 12 years, 15 years, and after this usage time, they come back and take it. So, but the beneficial part of this carpet is that it's even taking the dust from the inside air. It takes them into the carpet, and later when you vacuum clean it, this dust goes into the vacuum cleaner. So there were measurements made basically that prove that with this carpet, the room is cleaner as with a normal carpet. And this is what we mean with being beneficial inside the cradle-to-cradle system. And then overall, basically, I would like to use this poster, which comes from Michael Braumbart. He was exhibiting in the Biennale in Venice one day, and this was the poster of the booth, basically. And it basically says, building like a tree. And this is a little bit what's in the summary behind Cradle to Cradle. It needs to be a healthy indoor environment. The employees need to see that they like to come into this building. They are less sick. There's a project in Venlo, the city hall in Venlo, already up for many years. And there it was proven that the people are less sick basically than before in the old building. And the employees really like to come. Like 20 or 25 years ago, I don't know anymore, Google started to invent basically, you know, the football to play or the slide in these new office environments. So today the people are very concerned about health. So this is just a part that the people will like to come to the office. They have a benefit to be there because the indoor air is very good. And another thing is that cradle-to-cradle buildings don't pollute the surrounding environment anymore so much, because often we have also in the outer areas, we have claddings that have heavy metals inside, for example. And by the rain, they're washed out and basically distributed to the environment. This is, of course, not what we want. Here it's actually an interesting chart. It explains a VOC measurement, a volatile organic compound measurement in a school building, in a cafeteria in Germany. And I use this to show you on the bottom side here. You see this is the threshold basically. TVOC is on 3000. HCOH is on 120. So these are the maximum limits basically that are allowed. And here you see the measurements, and this was done when the building was still under construction. Yeah, so this was brand new. So you see that with the overall, the sum of all volatile organic compounds, we are on 6% of the threshold. On the formaldehyde, we are on 3.5. So it's significant, very significant low. And honestly, we still want to go down to 0%. But there are still things in buildings sometimes we do not know about everything. We are on the way of becoming better and better, but the target is, of course, that these bad things are completely eliminated out of a building. Here you see then another thing that is an idea that is basically coming out of the cradle-to-cradle system, because you can use cities and buildings as raw material banks, basically. So just imagine that you document raw materials that you use inside a project. Yeah? And we are doing this with the so-called building circularity passport. And in this passport, we write all details, which is connected to the BIM model. And Pascal will go in this deeper later. And with this, you have an identity of the raw material. On the raw material that has an identity suddenly has a value. And this value is something that you can use later after the usage time, because a steel beam or copper wires in the building are not becoming bad by using them in the building. They are still good. So it's a waste of not using this material. So in future, our cities will be raw material banks. And here I show you a little graph which should explain the idea, the financial idea behind it. So this green graph basically shows you the development of a standard building. You build it, it's used, a lot of things don't work anymore. So basically you need to renovate it. So the value goes up again, used again, and so on. And later you have to demolish it. Sometimes you demolish buildings, I don't know about in Finland, but in Germany we pay 500,000, 1 million euros because we have bad material inside and they're very expensive to get rid of them, basically. So the cradle to cradle is in the beginning a little bit more expensive, but also has a higher value because cradle to cradle means you have a better quality. And this also means that you have a better quality. Your value of the building is not decreasing so fast like in a normal building because the quality is better. Then you do a renovation and it's increasing less again. So there is opening a gap, basically, which you see here. The building can be used much longer. A cradle-to-cradle building is flexible, it's modular. Some buildings are built in the way that they become an office, but in the planning, you already think about maybe it needs to be a hotel or something similar back in the days. So we are very flexible with cradle-to-cradle. And the development of raw materials, the pricing is very likely to go up. In the last year, here we have a number here, is nearly 5% increase in 1 year. So it will become much more in 100 years. So basically, just imagine that the steel you pay 1 million euro for nowadays, maybe in the year 2150, you get 5 million, 10 million for it. So you even make money with it. So this is a very interesting approach, and our investors here, real estate developers, are really very, very keen on this. So, and now we switch to Pascal, please.
Yeah, thank you, Marcus. So Marcus explained a little bit on what the theory behind is, and what the principle is we want to use and apply to buildings. I'll go in right now a little bit more into what do we actually do in the projects and how do we do it. I'll have to tell Marcus to switch the slides sometimes, so please don't mind me doing that. Yeah, what we do in those projects is basically we developed a new new planning principle in planning projects. Because of course the cradle-to-cradle principle or the circularity is something that needs to be given into a planning process with someone that has the responsibility to do this as well. And this is the role of the circular engineer in those projects. And this circular engineer is responsible for making, as Marcus already explained, the building healthy, recyclable, and flexible. The whole circularity only works if all of those three properties are designed in a very good structure and work with together. So it doesn't make sense if you have recyclable materials but can't separate them from the other materials. This is why it's very important also to regard the dismountability and the flexibility in the building. If we look at the next slide, this is, you can see, Marcus already pointed that out a little bit, because of course the challenge in all that is it is not directly visible if a building is flexible or recyclable or healthy. This is why we need to display the properties or the circular properties of the building in a way that people can understand it. This is why we developed the building circularity passport. It's our approach on kind of an equivalent to the energy passport of a building regarding materials. So a material passport that includes all the information shown on the next slide about the materials that are used in the building, and also of course the values, which makes them a material bank basically. It shows, are those materials healthy? It shows what is the carbon footprint of those materials, because as we optimize the buildings for their energy performance, of course the embodied carbon of the materials gets a higher relative impact on the environment. So this is a topic that we need to regard in future more and more. We also have information on which materials are used. Is the building made up out of virgin materials, or are secondary or renewable materials used? We see if the building is recyclable, or which materials will need to be disposed of or can be maybe even upcycled. We see are the materials separate from each other, and of course we also see how the elements are designed. Are they dismountable? Are they flexible for changes in use during the lifetime? And of course this passport is also completely integrated with BIM if BIM planning is used. Marcus, if you can switch the slide. Hopefully this video works. So we see here that we developed a scheme with which we can display the properties, the circular properties of a building directly inside the model, so that we can see for each element in the model, is it downcyclable, is it recyclable, how healthy is it? And this of course gives a very good opportunity to also improve the building during its planning process, because we can show the building owner, the architect, look, here are elements that are still not separable as they are designed. Maybe we can try to put up a different connection in here, or maybe we can change the material in here to have it a healthier material, and yeah, therefore can integrate that directly into the planning process. Of course, the topic of embodied carbon or CO2 can be regarded here as well. So we can display clearly which elements have a high impact on the carbon footprint of a building, which elements have a lower impact and we don't have to regard them, and yeah, which elements will still need to be optimized. If you go to the next slide. Yeah, and this is, of course, by having that information and also the connection to the elements in the building, we can clearly display what happens with the building throughout the year. And we can, here an example for the embodied carbon again, we can show where is the impact of the building. Is it during its usage lifetime, or is it at the initial construction? So we can see where are the impacts, where can we optimize to design a building that is really cradle to cradle or circular. Next slide, please. And one thing that is very important that many people forget at times when designing buildings is that we need to look at the actual products, because often products are just regarded as generic materials. So we have a gypsum board, for example. The gypsum board itself can be produced with renewable energy, can be produced with healthy materials, can be produced with harmful materials. This is why it's very important to look at the actual product when documenting or rating a building for its circular properties. And because of that information is at the moment very hardly accessible, we developed a solution for that, which is the Building Material Scout. This is an online database for products, basically, with sustainability properties. So there are any kinds of products on it, but the strong focus is on which properties regarding sustainability do they have. If you go on the next slide, you can see that the principle works like that we have, on the one hand, the manufacturers putting in their information themselves. The benefit for them is that based on the properties that they put in about their products into the platform, there is an automated assessment methodology that rates the product according to the green building schemes. So if a manufacturer puts in, my product doesn't contain cadmium, my product doesn't contain this and that, the platform automatically tells them if the product is compliant for LEED, for BREEAM, for DGNB systems, which is an advantage for him. And also, on the other hand, an advantage for everyone that wants to use the product, because they can filter and find products through the platform by selecting just the right properties they want. And we, of course, also use that information then in the documentation of our building projects and also in the optimization to have the real product information available and not only generic material information. Okay, so this for the theory. as the last point, we'd like to point out some references so you know that this is not just a theoretical talk, but it's already happening on a daily basis that we're doing this. So the first project where we implemented that was the RRG project in Essen in Germany, which was part of a scientific project as well, which was called Buildings as Material Banks. This was a pilot project where we tried to optimize the building in all layers of the cradle-to-cradle principle. We also integrated that with our colleagues from Dresden Sommer, who did the other consulting services or planning services for the construction. We can see here that we have a rooftop that can be accessed by public. We have a facade that has been specifically developed for C2C properties with Schüco together exactly for the project. We have it's a flexible modular system. We have photovoltaics on the roof, of course, and it's also certified DGNB Platinum. So this was the first project, but there are many more. For example, a bit of a smaller project, but shows that it also can be done in a smaller scale, which is a how you call firefighters' house in the Black Forest here in Germany. We also have, of course, bigger projects like the Schüco project, which should be on the next slide, which is also a very innovative project because it's the first building that's going to be certified with the highest levels of the DGNB, LEED, BREEAM, and will be designed according to the cradle principles. This is called because Schüco as a manufacturer itself also wants to drive on it and wants to show that something like this is possible. We also have international projects like, no, that's the wrong one, but this is a very, very detailed project as well, where the building owner said he wants to really have the name on it, so this is why it's called the cradle. And there we developed really developed new systems that are implemented in the building. So, for example, the wood that is used is not treated at all, so it can be really recycled and not has to be burned or disposed of in the end of its useful life. And for the next building, I think this is the project in Luxembourg where first to Moringa. Okay, this is one of the first residential projects that we have, which is in Hamburg. It's also completely, since the first hour of the project, designed according to the cradle-to-cradle principles. The architects and also, for example, on the facade, the elements are completely reusable. Also the vegetated elements on the facade. And yeah.
Thank you.
This is for now. Thank you very much.
Thank you very much, Pascal and Markus. Very, very interesting presentation. We have time for one question. There was in our chat there was one question, and that concerning the market potential. So it was asked, how much is the market until now for cradle-to-cradle type buildings, and how do you see the future potential? How it will develop?
Okay, maybe I can explain my personal point of view there by just telling, when I came back from China and started this position here in Germany, in Hamburg, we had maybe 2 or 3 real estate projects in cradle to cradle. And I would say today we have over maybe 12, 15 running. The situation changed tremendously. And first of all, we call this a little bit the Greta impact. Greta moved the people a lot, that they really consider what is actually sustainable. Everyone used this word sustainable. no one believes in sustainable anymore because it's too much a marketing gig. And now the people want to do it really seriously, and the people feel that the ways that they have, that there's a problem with, and architects are usually also very sensitive. So this topic overall is booming, I have to say. It's increasing a lot. There's a lot of companies, a lot of engineers who are starting to offer their services. And we believe even that in future, I have to speak for Germany because I'm a little bit more familiar with the laws here, that in the future, of course, you need here an energy efficiency passport right now to prove that your building is only consuming a little bit of energy. And we are very sure in future, you also need to tell when you have the approval for your building planning, what is happening with the building if it's not good anymore, if you need to demolish it. And you need to prove that you have a concept that most of the material are reused and circle. So we are very sure that this is the future of architecture.
Yeah, we see that especially in Germany, also with the legislation that's happening right now, because right now there's going to be a law put out just by the end of this year where the manufacturers of products will have to take the responsibility for the disposal of the products. And this is something that makes clear that yeah, this responsibility for a good design will be more and more in focus in the coming years.
Right. Oh, thank you very much. Thank you. Good. Now
I think we have one more question.
There is one more question from the chat, and we are going to come back to you via email and provide an answer. We need to move on right now.
Yeah.